Hey everyone, it's Timmy Gobbles. Today's video goes out to Sloppy Glizzy 8313. Wanted to know more about walker generation. And one of the games he mentioned was Nuclear Throne, which uses something like a modified walker generation. So today I'm going to be using this tile map from Kenny to show an example of how I would make a walker generation. Well, like a walker generated level. I don't know. What a mouthful. Anyways, so we need a scene with our map, and it needs a tile map and a camera. And I didn't know what size the tile set was, so I made a quick Sprite 2D to figure that out. Okay, so now we need to pick a couple tiles to be terrain and a couple tiles to be walls. So some things need to be walkable and some things need to collide with the player. So I'm going to use these little tan tiles to be walls, and I'm going to use the grass to be walkable terrain. And I've added a physics layer so that I can add collision to the walls. And if you click on one of those tiles, you can just hit F and it'll go ahead and fill the whole tile with collision. I wasn't sure if I wanted to use these gray bricks as well, so I think I set some of them up. If you don't know how to set up a tile map, I'll link one of my videos that explains it in better detail below. Alright, next, we need a class that walks. And so it needs to have a position and a direction. And we should probably give the class a name as well. So I'm going to go by the naming convention in that article and call it Floor Walker. I'll link the article below as well. So the position and direction, I'm going to represent both with vector 2i's. And the direction is just going to be the 4 cardinal directions: up, left, down, right. Next, I'm going to write a function for walking. So in order to take a step, we just add the position to the direction. And now we need to think about rotating. To do this, I'm just going to have a constant that holds all 4 of those directions. In this case, right, up, left, down. And notice they're in order of rotation. So if you followed them, it'd be like a clock going backwards. And rotate is going to take in an argument for, rotate, the number of times we want the walker to turn left. So 0 would keep the same direction, 2 would flip it 180 degrees, 1 would turn it left once, and 3 would turn it right. So I thought it would be neat to use the mod operator and that cardinal direction array to modify the rotation. And now that I'm thinking about it, I'm going to write an initializer while I think about how to do that rotation method. So a new walker needs a position and a direction. And we'll have those default to the 0 and right constants in vector 2i. Next, if we take directions index and cardinal directions and add it the number of lefts, and then apply the mod operator, mod 4, we can assign direction that new index from cardinal directions. Essentially, this just wraps the cardinal directions around onto itself. And I like to make a couple scenes in my projects for just testing code, and so I have this code test scene that I'm going to go ahead and test out that rotate method with. So if we take a floor walker X and we print its direction, and then we rotate it left in a loop 5 times and print its direction each time, and then we'll rotate it right by passing -1. You could also pass 3, that would be fine. And there we go. It seems to be working correctly. Remember that the y-axis is flipped. So 0, -1 is actually up, and 0, 1 is actually down. Alright, next I'm going to make a class called Level Maker, and it's going to use floor walkers to generate a floor plan for a level. The article said they generate 110 tiles, so that's what we'll do as well. And this make floor method is going to need to keep track of the floor walkers, the tiles, which we're going to call floor, and we're going to go ahead and throw 0, 0 into the floor as a starting value. Now, walkers aren't restricted from walking back on their path, so I want to come up with a way to avoid adding tiles into floor that are already in there. And one way would just be checking if the floor has the new tile and then ignoring it if it already has it and adding it if it doesn't. But I want it to be slightly fancier, so I'm going to create this binary insert lambda inside of the make floor method. So the way that the bsearch method works, and this is for arrays, if you have an ordered array from least to greatest, it'll find things faster than find or has, because it's working with the assumption that the array is sorted. So it'll look at the middle index, and if the find value is greater than the middle index's value, it'll search between that middle index and the end index. And so each time it does that iteration, it's looking through half as many elements. And so it ends up being a little quicker. And if you look at the method in the docs, so if it returns a value less than the size of the array, then that would be the value you would want to insert it at to preserve the sorting of the array. So 0 would mean that it has a smaller value than every other element in the array. And if it's the array size, then it's greater than the other value, so you'd want to put it at the end. And if it's somewhere in between, then that's the index you would want to insert it at. Since there's a bsearch, I wish there was a binsert function, but I don't think there is. Maybe that'll come with the new update. But anytime I do one of these, I always mess it up, so I wanted to make sure I got it right before I just threw it in my code. Okay, and you can see here, it's adding it in if it's appropriate and not adding it if it's already in the array. All right, so I'm going to take that code from code test and slap it into this make floor function. And to define a lambda, you do it the same way you define a variable. You say var, then the variable name. Oh yeah, there was an error here. You guys can fix that if you're following along. I fix it later on, but you know. And then that lambda, you do equals func, and then you basically just write how you would a method. The only difference between a lambda and a method is to call a lambda, you have to do .call instead of just open parentheses and then the arguments. Okay, so let's make a big while loop. My last couple of videos have had big while loops. I'm not sure if that's a good thing. Okay, so for each floor walker, we want it to take a step, and then we want to rotate it randomly. So we can just like randi range 0 to 4. And then we want to insert that new tile into the floor if it's appropriate. And then at the end, we just return all the floor tiles. Now moving over to that scene where we display it with the tile map, I'm going to export tile map in camera just to make things easier. And when you make export variables, you need to remember to assign them. I oftentimes forget and then I get an error. And I'll make the level walker or the level maker a onReady variable. I'm not sure if that's necessary or not. In the project settings, I'm going to go ahead and set up a couple buttons I can use while we're generating these. Probably could have added this part out, but here it is. Okay, and so we're going to set up the input function to accept, I think spaces, I'm going to have it make a new level, and that's all we need for now. So now we need a make new level function to call when we hit the space bar. And I'm going to go ahead and look at the tile map to just kind of pre-set up that grass tile so I don't have to just kind of use it as a magic variable. So we want to iterate through each of those floor tiles and set it on the tile map. Oh, and at the beginning of the method, we want to clear the tile map. And then we want to go ahead and move the camera to the center of the used tiles in the tile map so we don't have to move it around. And I'm going to go ahead and set up a like zoom in and zoom out function for the camera. And by function, I mean it just kind of does it. So in this case, it looks like up is zoom in and down is zoom out. Okay, and here are some walker generated dungeons or maps, or whatever you want to call them. I'm just kind of mashing the space bar to spawn a new one. So for the rest of this video, I'm going to be modifying the floor walkers using that article as reference. So first mistake I did was calling something floor, since that's actually a method. So it's kind of confusing to call a member floor when it's already a name for something else. Alright, so fixing that, everything's fine. I like to check every now and then after I've edited a bunch of junk. So I wasn't sure if I wanted walkers to always take one step. So I went ahead and made step return an array instead of just a value. And because I changed it in floor walker, I also had to change it in make floor. Next is in the article, the chance to rotate a floor walker isn't uniform. So I need to be able to set up a like a probability chart for how many lefts the floor walker takes. And also, instead of returning nothing, it needs to check if it turns it around 180 degrees. Because in nuclear throne, if a floor walker does that, it spawns like a weapon cache or something. Some kind of item is based on it. Next, it has different floor walkers based on the map. So I thought I would go ahead and make a class that inherits from floor walker and call it sand walker. So this was for generating a desert level. So you can just change what it inherits from, and it'll inherit all of the methods that you put in the parent class. And we can go ahead and override the rotate function and go ahead and set up that RNG. So I'm just gonna get a random float from 0 to 1 and then use some if statements to check whether or not we want to rotate it. And I can just use the parent rotate function to actually change the direction. So if I want to turn left once, then I'll call super.rotate to 1, and recall that the parent rotate returns a boolean. So I want to go ahead and pass that through when this version of rotate gets called. Next, let's go ahead and test to see if that works inside our make level. So I'm going to replace floor walker with sand walker and get these kind of wonky shapes. Next, I wanted to see if I could hold an array of types so that it was easier to change what type the level maker uses as its floor walker. And that ended up working as a variable, but I couldn't use it as a constant for some reason, which is kind of neat. So if I take the first element of walkers and call .new, it returns a sand walker. And if I take the 0th element instead, it's going to return a floor walker. So I went ahead and set up an enum to take care of that. I don't think I ever got around to making the sewage walker, but the idea stands. I think you could also use the dictionary. Alright, next, the floor walkers have a chance to split, which means basically to spawn another one in its location. So I'm going to put that in the parent floor walker, and then it's going to have a chance to return true, which means level maker would want to create a new floor walker at that position. And I'm going to go ahead and make the floor walker type enum and input into the make floor function. So that way we can change what kind of floor we make just by changing that input value. And it's going to default to the base floor walker. And also in that article was that there's a chance for floor walkers to die if there's too many floor walkers. So So we're going to kind of put that in the while loop as well. So far the order is take a step, rotate. I think it's going to be split, and then whatever else we do next. Oh, so if it does a 180, we need to add its, or that location to the weapon caches. And so if we're removing the floor walker, we should probably also skip anything that happens after. So I'll use continue inside that if. All right, then I guess we're gonna check to kill before we split. So let's check whether the floor walker should split. And if it does, then it needs to add a new floor walker on the array of floor walkers. And we'll go ahead and set that new floor walker's position to the same as the current floor walker, and we'll make its rotation random. We can just pick a cardinal direction, or take the cardinal direction array and pick random. All right, we should test it out. I think I'm gonna bump up the number of tiles to 210, and I'm gonna bump up that chance to split as well. So here we get slightly different paths. I can't tell much of a difference, so maybe I have some more tweaking to do. But some of them look a little different. I'm not sure if it's here, but there was some point I was hitting space instead of enter, and so I was using the wrong floor walker, but maybe that comes up later. All right, so let's look back at the article. I need to think about making rooms. So some floor walkers have a chance to drop a 2x2 or 3x3 room at their location. So let's go ahead and make a drop room function in floor walker. And it's going to return an array of vector 2i's. Okay, so in the loop, we need to, I was just checking that input worked. I hadn't set that up yet. Oh, let's change the order of the inputs so we don't have to set the floor tiles anytime we want to set the walker type. And we'll go ahead to that scene with the tile map, and we'll make the walker type an input. We can just treat it as an int because enums and ints work well together. Oh yeah, so this is where I want spacebar to be regular floor walker, and I think enter to be the stand walker when I'm testing it out. And I wanted to make sure that the floor walkers were killing themselves when there were too many. That seems to be working. Print statements are helpful, but you have to clean them up when you're done with them, or else you just have a bunch of junk to look through. Next, let's overload the make room function in Sandwalker. So it also needs to return an array of vector 2i's. And again, we're going to call for a random value. And if that value is good, it's going to keep doing the code. Otherwise, it's going to return an empty array, which means we don't have any points to add. Otherwise, it's going to add this array of 3 points that are around the floor walker's position. So we can just iterate through the tiles that return from that function and insert them into the floor if they're appropriate. And so now every now and then there's a little chunky block of blocks or tiles that ends up on our generated map. Now that most of the floor placing is done, let's look at more of placing pickups. So I had weapon caches, which I'm going to rename weapon chests to be in line with the article. And we also need two other kinds. There's ammo chests and there's experience canisters. And all these in the level maker, we're just going to represent by their position. So we can just keep them as arrays. So from the article, weapon chests are when a floor walker turns 180 degrees, and the ammo chests are when a floor walker dies, and the experience canister is from the last or furthest floor walker at the end of generation. So now we have something to do outside of that big while loop. We need to look at the floor walkers and append their position to the experience canisters. I like to keep my warnings to a manageable level, so I went through and cleared out these like kind of inconsequential ones. Otherwise it gets too hard for me to manage. Alright, and since I'm using set cell to set the floor, we're also going to use set cell to set these pickups, just as like placeholders. You'd want them to be their own kind of class that could interact with the player, but just for visualization. So I'm going to grab a couple of these smaller tiles and I'm going to add a new layer on the tile map. And so I want to set the cells for these pickups to be, I think it's like a barrel and a shrub. And I'm also going to have the player position show as well. All right, so after we've placed the floor, we're going to iterate through the ammo chest and the weapon chest and the experience canisters, and go ahead and set those in the tile map. So set cell, the layer is going to be 1 instead of 0. The tile we're getting from that array, so that's easy. The source is still 0. I mean, that depends on your project. And then I just went ahead and copied in those tile set tiles, array 2 eyes into there for the atlas tile that it chooses. Okay, so now that I have a floor and a start position and pickups, I need to think about walls. And if I want to think about walls, I want to think about the range of the tiles. So I'm gonna just basically look at a rectangle that encompasses all the floor tiles, and I'm gonna use that when I want to decide where to put wall tiles on my tile map. So if I look at each tile in the floor, each floor tile, I can check to see if its X is smaller than the top left corner X, and or if it's bigger than the top right corner's X, and I can go ahead and change that corner. And I'll do the same thing for the Y values. I called it set grid because I was going to use a grid class, kind of like how I used in the maze video, but I decided against it, and just to show a different way. So don't be confused by set level grid, that's going to go away in a little bit. And sometimes it's just hard coming up with the way I want to do this kind of operation. You can actually just use the rec2i class, and it has some function that just like grows it to include a point. So you can just call that for each point in the floor. But I don't know, I ended up doing it with this stupid loop. It's kind of the same thing. So 6 of one, half a dozen of, or whatever the saying is. So instead of using the ifs, I'm gonna use min and max instead. And that ended up just being easier. So we just have 4 checks to make, and that should come up with a appropriate rectangle. You can also use, the tile map has this like use tiles rectangle, but I wanted to keep the level maker separate from the tile map, so that's why I included it the way that I did. So then once we have that rectangle, we're going to need to find a way to iterate through all the tiles in that rectangle and choose whether it's going to be a floor tile or a wall tile. And there's going to be 2 kinds of wall tiles. There's wall tiles that have a floor right below it, because that'll visually look a little different, and there's wall tiles with a floor above it to kind of give it an effect that looks like the camera's at an angle instead of just kind of orthogonal to the floor. And I need a function that checks whether or not a tile is in floor. So we just use bsearch, and if it's less than the size of the array, then we need to see if it's equal to the element in that array, equal to that index. And if not, then it's just not in the array. The size of the floor, the size of the floor array, then we know it's outside of it. All right, I'm going to modify the get level rect to return a rect2i because I like working with that class. I'm familiar with it, I guess. So we'll set the position of that rectangle equal to the top left corner that we found and the end of the rectangle to the bottom right corner. And then we'll just return that rectangle, or rect2i, whatever you want to call it. And I guess I decided I wanted to hold it as a variable. So we'll go ahead and get rid of the return value and just end up assigning it. That's fine. All right, now that that's set up, we want to think about iterating over all of the tiles in that rectangle, including the bounds, including position and end. So to loop over the x, we're going to take a range from the position.x and go to the end.x plus 1. And similarly for y, it's going to be range rectangle dot position dot y to the end dot y plus 1. We need to do the plus 1 because range stops 1 short. So then that's going to make us a tile vector2i xy, and we need to see if it's a floor tile. So we're going to call that isFloor function. Now if it's a floor, we need to set the tile map appropriately, and if it's a wall, we need to set the tile map appropriately. If it's a wall, we also need to check if the tile below it is floor, and if so, that's going to be that other kind of wall. Oh, and I've got an error. It seems I forgot to type the level bounds. So I'll go ahead and go back and all right, that looks good. All right, this is okay, but it's the top and sides of the rectangle are cut off. So I might need to do a little bit of padding on that loop, and I kind of don't like how the wall looks. I might need to pick a different wall tile. So I'm gonna start with the wall tile. If I go to the 2D editor, I can look through some combinations of the wall tiles for the kind of look that I want. And I tried a couple of these out, but this might just not be a good tile set for this project. I might need like a different kind of look. But I'm pretty bad at art, so what do I know? And I even got a little desperate, and I ended up making an alternate tile to like flip up down to try out, and that also looked kind of weird. But I ended up settling on this one, and I think it looks good enough for what I'm trying to show, so no big deal. So I'll go ahead and set up wall and wall top constants, and there we go. It kind of looks better. It kind of gives the illusion of a 3D, but not really. I don't know. Okay, and I've set up a pad variable, and I'm going to go ahead and add that and subtract that. I'm sorry, subtract and add it. And that way that rectile expands out a little bit. A note that this would be really inefficient for a walker that just kind of shoots in a diagonal shape, because you'd end up with a very big rectangle compared to how many floor tiles you have. There's probably a lot better way to do this. But all the ways I could think of used grid, so either way you're using something gridular. Like here I changed the rotation settings to just not. Alright, there we go. This is looking better. I'm gonna bring the pad value down. I didn't think it needed to be as large. It depends on your camera zoom, I guess. And I went ahead and turned on visible collision just to show that the collisions are working from the tile map. And I think that's about it for today. There were some more points made in the article, but the video's long enough. So hope this was helpful, and hope you all have a good one.